So, this is our lecture number 4. Please mute yourself. Okay, earphone use करो. Okay. So, today we will discuss one more topic from this transducer, and from next lecture we will start from your rest of the topics from CT and PT. Okay. So, if I talking about in terms of transducer, so this is one of the very important, uh, that is a thermocouple, which is in industry. There are it has a lots of use, and thermocouple are generally measuring from moderate temperature to a very high temperature. Okay, so today's topic is thermocouple. See, thermocouple is work based on your Seebeck effect. Okay, actually, what happened in that, there are two different kind of metal are joined together, and when they are joined, so it create a junction. So and a different temperature, when observe these metals, it create a potential between that two junctions. uh, Sorry, uh, create a potential. So one of them is a hot junction and one is cold junction. So hot junction is generally has a higher potential compared to the cold junction, and you can also vary, means because of the Seebeck effect, the potential is created, right? Because of the circulating current is flowing on that, due to this temperature differences. So you can also measure the mm, this potential with the help of meters. Okay, multimeters and other meters are available to measure the voltages. So if I talking about the principle, this thermocouple is, so let's start from the basic. What is thermocouple? Actually, the theoretical part you can also refer from that book, Halsey book, which is I already put in your Google Classroom. Actually, they are e-copy, e-PDF. So I think in that there are some pages are missing. So I suggest you to go library and use that from that. So this is a device which is used for the measurement of temperature variation. Now, as I explained in previous classes, if the any transducer or any circuitry in this, uh, it if it is not required any external sources for its working, then that type of device put under the this active transducer. Okay, if it requires some external sources for their working, then that devices is put in the passive transducer, as a passive transducer. So this thermocouple is active transistor. Okay, it means it does not require any external energy sources for their working. Whenever the difference in temperature is created, so because of that, a current is flowing within that circuit. Okay, so this is your active transistor. Yes, please come. So in its working, there are three kind of principle. First is Seebeck effect, second is Pottier effect, and third is Thomson effect. So generally, Thomson effect we neglect for their working because its potential uh, is very less, and it does not affect your overall operations. So generally, we are neglected. But yes, there are also the Thomson effect if we see the working on in this. Okay, generally, for example, this is a one metal, and this is a second metal of wire. You are just connect that metal, so it create a junction. Okay, so this create a junction. So let's say this is a junction 1 and this is your junction 2. This is a metal A and this is metal B. Now, uh, Seebeck effect, the same which I explained. Seebeck effect is nothing but here the temperature, due to these temperature differences for these two metals, it create a uh, circulating, it flow the circulating current within that. So this explained in Seebeck effect. Okay, and why this circulating is flowing in that circuit is explained by the your this Peltier effect. Okay, इसमें circulating current क्यों flow हो रहा due to the this difference in their temperature, right? That reason explained by this Peltier effect, and circulating current flowing in that circuit is observed by your Seebeck effect. Okay, if the current is flowing in that, so it means you can there is a potential is created, then only this uh, such a condition is arise. Okay, so if I talking about the sentence in terms of sentence, so see, this effect state that when two different, or you can say unlike metals are joined together at two junctions, an electromotive force is generated at the two junction, and their amount of that force is depending on the uh, types of metals which you are using and the temperature differences. Okay, and second is this Peltier effect. Now, if this is a, for example, for two metal connection, right? Two different metal connections. If there are number of metals are connected in different combination, so for each connection there is a junction. So at each junction there are some potential are created. Okay, so that explain with in this Peltier effect, and that why this potential is created due to the difference in temperatures. Okay, so I just write here when here I'm considering only two metals. Okay, but the concept is follow for a number. If metals are number of metals are increases, then also this concept is follows. Okay, when two dissimilar metals are joined together to form two junctions, EMF is generated within that circuit due to the difference due to the different, or you can say different temperature of two junction of the circuit, right? And the Thomson effect is third is Thomson effect. We generally neglect this effect. Okay, actually, mm, see, so you can measure the voltages with the help of this junction. This is a junction one. So here I consider this is a hot junction, and this is the second junction, which is considered as a reference junction. Okay, or you can also say that this is a cold junction, and from there you can measure the voltages, or you can the supply the voltages uh, for measuring the temperature. Okay, S- now this is M1 metal 1, and this is M2 metal 2. Now in Thomson effect, if this is a condition, or when you want to measure the voltages, so such a condition when these two dissimilar wire is connected, then one is a reference junction which is a has a low voltages, or one is a hot junction. Hot junction, there are some electrons diffuse in a cold junction when this connection is happen, and uh, temperature the difference in temperature is applied on this two different dissimilar metals. So actually diffusion of electron is happening, and that diffusion due to this hot temperature, the that electron is follows to the your cold junction. So this potential, this junction is become a positive. This potential become a positive, and this become a negative. So this is a one of the two junctions. So such a condition is also arise at the different parts of their metals. So Thomson effect say that it has a means every molecules has their capacity to generate the EMF. So that's all are explained in this Thomson effect. Okay, if I explain in terms of this statement, then you can write here when two unlike metals are joined together to form to junction, the potential exists within the circuit due to temperature gradient. And this due to this temperature gradient, the electron is diffusing to the reference temperature. Okay, gradient along the entire length of the conductor. So for each and every entire length of the conductor, right? So हमें जहाँ से वोल्टेज निकालना है, आप सिंपल वो दो पॉइंट का मेजर कर लो. So for example, this is a nothing but your Kirchhoff law, right? KCL, summation of each node, in summation of all uh, entering current. KCL में क्या था, summation of all current at particular node is equal to zero. So same similar way, you can say that this is a series combination of the circuit. You can just add all the voltages if the potential is in proper manner. Okay, so that's why this Thomson effect we are generally neglect for a particular, you know, for entire entire part. Okay, so this thermocouple is based on the three principle, and you can for theory you can follow that book. Now I'm just discussing the property of the thermocouples, uh, and also discuss one question. Okay, based on that.
What is reference function exactly?
Sorry.
And the reference function, right?
Reference junction is a junction generally. Observe the temperature is for reference junction. First is reference junction का temperature लो रहेगा, right? वाई ये रहेगा, क्यों लो रहेगा? क्योंकि जब भी आप व्हेन यू सी द इन इंडस्ट्री, देयर आर number of connection are there with different metals. For example, in बॉयलर के अंदर में आपका डिफरेंट जो लाइंस है. Okay, so there are some such a arrangement which do the connection of different metals. So for that, there are we have to set the reference temperature for the particular the production of uh, any मटेरियल यू कैन से, जिसका भी आप प्रोडक्शन करना चाहते हो, उसके लिए एक रेफरेंस टेम्परेचर लगेगा वहाँ पे. सो फॉर दैट, जब भी आप उसमें कनेक्शन करोगे, जैसे कॉइल वगैरह रहता हो उसमें, so for that you have to know the what are at what value you get this at what temperature. Okay, at मीन्स कितने टेम्परेचर में कितना इफेक्ट आपको वोल्टेज मिलेगा और कितने वोल्टेज से, मीन्स वाइस एंड वर्सा. सो फॉर दैट उसके दो टर्मिनल रहेंगे, राइट? फॉर एग्जांपल, दिस इज योर वन कनेक्शन एंड दिस इज योर सेकंड कनेक्शन फ्रॉम दिस. ओके, सो दिस इज योर वन एंड, एंड यहाँ से फॉर एग्जांपल आपका सोर्सेस हो जाएगा. Okay, if some sources are connected to this, So this is some you can say boiler. Let's say it is a boiler. So these are the coiling under this. So for that, how much is heat is generated from this? So that's all study is comes under this condition. So ये वाला जो condition है वो voltage का, so वो यहाँ पे हो जाएगा. ओके. एंड द रेफरेंस टेम्परेचर्स हम सिर्फ इसको फाइंड आउट करने के लिए निकालते हो वोल्टेज को. ओके. जैसे आपका रेफरेंस टेम्परेचर्स है यहाँ पे वोल्ट कुछ कनेक्शन में जब भी टेम्परेचर डिफरेंस क्रिएटेड होता है तो आपका इलेक्ट्रॉन एक रेफरेंस के तरफ फ्लो करता है. सो जब आप उसे आइडेंटिफाई करते हो, सो उसे हम एज अ रेफरेंस कंसिडर करते हैं. ओके. एंड फ्रॉम दैट यू कैन ऑल्सो फाइंड आउट द डिफरेंट काइंड ऑफ दिस पैरामीटर्स एज वेल. सो या तो इसको किसी इंडस्ट्री से रिलेट कर लो, या फिर आप घर में जो पानी गर्म करते हो ना, वाटर इस हीटर, तो उससे भी कंसिडर कर सकते हो. Okay, so actually, this is for your understanding. When we solve the problems, so there are some reference are given to you. So at that time, you need to consider that reference, and when the number of these wires, or you can say metals, are connected, so there are some references. According to that reference, you need to set up the polarity of each junctions. And when you find out the net voltages or potential for overall the circuitry, so that reference, because of that reference you create the this signs, right, potentials, and for that, which is helpful for find out the overall effect, ओवरऑल पोटेंशियल निकालने के लिए वो काफ़ी हेल्प करता है. सो दिस इज़ अ न्यूमरिकल इसमें इसका एडवांटेज है. एंड इंडस्ट्री लेवल पे मेरे को ज़्यादा तो पता नहीं है, जितना मैंने बताया इतना है, बट आप और सर्च कर सकते हो. ठीक है. बट न्यूमरिकल्स में इसका काफ़ी यूज़ है. ओके. सो दिस इज़ अ now we will see different combinations of mm, this connection, and what are the effect. So first of all, this is your junction 1 and this is your junction 2, and let's say it has a some temperature which is T1, and it the junction 2 is T2, and some current flowing in that circuit I. This is metal A and this is metal B. So this is a circuitry, and what are the formula for that? If you want to find the potential is, which is represent here in terms of E. E is nothing but your directly proportional to the variation in temperature, right? Between these two junctions, between two these two junctions, for the overall voltage or for a particular voltages between two these two point. Okay. So generally, this proportionality constant, when you remove this proportionality, you just mention here sensitivity into this change in temperature. So this is nothing but your sensitivity here, and generally specify in terms of uh, depending on that volt per degree Celsius. Okay. So first law, you can say, if there are uh, two metals are joined and it has T1, T2, these are your two junctions. Okay. And the intermediate temperature is also known to you, which is, let's say this is your T4, T3, T5, T6. This is A and B. And if you reconnect the circuit, uh, if you reconnect this circuit, but the potential of T1 and T2 are same for the same metal, and you observe that this intermediate temperature are changing. Okay, this is A and B. So let's say this is your E1 potential, and if you observe that this is your E2 potential when the intermediate temperature are changing, that is T10. Let's say this is different temperature, right? So this I consider T7, T8, T9. Then you can say that the potential created with this with this first circuit and second circuit is almost equal. Okay, so this is the first law. Second is,
Hello, sir.
yes,
So, what is intermediate temperature?
intermediate
If I
means, see, nearer to the temperature, यानी इसके बाद कौन सा टेम्परेचर आएगा, इस ये एक मेटल आपने कंसिडर किया, ठीक है। सो ये एक मेटल वायर कंसिडर किया, सो आपने जहाँ पे कनेक्शन किया उसके नेक्स्ट बाद में आपने जहाँ पे भी टेम्परेचर चेक किया, जहाँ पे टेम्परेचर डिफरेंस आपको देखने को मिल रहा था, ठीक है। सो यू कैन कंसिडर एट दैट intermediate temperature and the same distance when you observe the this at a second position. So what are the if you find the different temperature due to the different conditions of your surrounding, then you can say that uh, and for that, for this there is a potential created, right? So at the end, when you conclude these two things, because of the this potential and this potential are same, because of this potential and this potential are same, so you can say that this EMF generated with this circuit and this circuit is almost same. Okay, so ऐसी condition, this condition is generally used in industry. First of all, this is your known condition, right? If any other circumstances is happening here for your plant, so mm, such a rules are very useful uh, to calculate the EMF, or you can say other parameter which is need uh, for which is needy for your do the solution. Okay, so this is the first law, and second thing is this is a thermocouple which is a AB. This is junction T2, means temperature T2 on junction T2, and this is temperature T1. Now if you cut this metal to metal B, and if you cut this metal B and add a new metal to this, mm, if you cut to this metal B and add a new metal which is I consider metal C. Okay, this is your A and this is your B, and you cut and add metal C with, and this is your B, right? So and the temperature is same for this end T1, and this is your T2, and this junction is created a potential with sorry temperature with this common temperature, which is I consider here TT. Then the overall effect is also same, which is E1 is equal to E2. So let's say this is your E2 and this is your E1. Okay, and third is the same if this metal are uh, cut at one end and coupled with the different metals. Okay, so if this part is cut and add a new metal from this, and the potential is observed, and that junction is, let's say this is T and this is your T, the common potential is observed for this part, and this is your T2, and the metal is same, A and B, and the potential for this condition is E2. Then also your this potential is almost same for this condition. Okay, and fourth one is, this is your T1 and this is your T2. In that, in that, if you add a new metal, if you add a new metal with the combination of B, let's say this is your C metal, and put the temperature the same, which is T2, T1 and T2, then it create a potential with E2. Then the mm, net effect when you add this two dissimilar metal, which is metal A and metal C, at that time what are the net voltages or net potential is observed across that circuit is, this is A and this is C, let's say. So this temperature is same for all these three cases. Then what are the effect of voltages in that is nothing but your E1 plus E2. Okay, now see here the metals are different. First is metal A and metal B, second is metal B and metal C. And if you want to add this metal A and metal C, so the sensitivity parameter are changing. Okay, so for that the voltages is also changing for this circuit, and that voltages or potential, we generally observe that the summation of these two combination. Okay, and fifth one is T1 and T, which is A, B, E1. T. So if these two metals are used, which is A and B, and it has a potential T1 and T for this first condition, and when this same circuit, or you can say uh, metals are observed at different temperature. Okay, one temperature is same but other temperature is different, then what are the net effect observed under this condition of these two different temperature, which is T1 and T2? जब आप इस पे इसका नेट इफेक्ट देखोगे तो क्या मिलेगा आपको? This is your E. Okay, this is your E. So E is generally observed E1 plus E2. Okay, so these are the law for this thermocouple. So you generally remember this all these things while solving the problems. And there are also the different types of different types of this thermocouple. You just go through that book, okay, and for example, J type, K type, T type, E type, such a types of examples are given in there, and there according to that their range also specify, okay, range also specify. So take this, range also specify. So just go through that and find out at what type they mm, you can measure the maximum temperature, okay. So according to this there are also the different combination are there. So you just observe mm, at what type you are using, at what uh, टाइप ऑफ मटेरियल, ओके, कौन से टाइप के लिए कौन सा मटेरियल यूज करना है, दैट ऑल्सो गिवन इन दैट नाउ. So this all about the thermocouples. So take one examples, solve these examples, write down the question. The Seebeck coefficient in microvolt per degree Celsius. See, this is the unit of sensitivity, right? So you can also say that the Seebeck coefficient for the copper constant and iron with respect to platinum. Now, in this thermocouple, platinum जहाँ पे भी दिया होगा ना, उसको एज अ रेफरेंस यूज करने का, राइट. यू कैन ऑल्सो ऑब्जर्व दैट, सी हेयर, आई फॉरगॉट दिस पॉइंट. For example, these are the metals are joined. One is copper, which is, and second is platinum, okay. One is copper, second is platinum, and you want to measure the sensitivity of the overall the systems. So these are the junctions, J1 and J2. It has some potential T1 and T2. So generally we observe that we are taking this platinum as a reference. Generally we are using this platinum as a reference, and the sensitivity, of the overall system means system sensitivity is equal to the, so this is taking as a reference. So it's, as a sensitivity is considered as a 0, okay. Platinum has a sensitivity with 0, so it take as a references. So whatever the so it has a 0 sensitivity, it means it create a negative potential, okay. Because of that it has a 0 this sensitivity, so EMF for that is 0 for particular this. So whatever the junction is created, whatever the EMF is created in that is only for due to this copper wire, right. So that's why this sensitivity of copper minus sensitivity of platinum, and for the in general this is 0, okay. So sensitivity of overall system is your copper. So that's why we are using as a reference whenever the platinum material are given to you. Use that material as your references. So this potential create positive and this create negative. So the current start flowing from this side, okay, from higher potential to the lower potential. Now this platinum, the values are 1.9 minus 38.3 and 13.3 respectively. The magnitude of the thermo EMF, let's say E, developed in the circuit shown in millivolt is. So this is your circuit. Let's say this is your constant and wire, and this is your copper wire, and this is your iron wire. Okay, this is given in your question. Okay, this potential is given in your question for this particular question, and for in that T1 is equal to 0 degree, T1 equal to 0 degree, and T2 equal to 50 degree, T3 equal to 15 degree. Okay, this this is a data is provided you in this question. This is your constant and this is your copper and this is your iron. Okay, so this data is given to you. You need to find out the uh, this potential developed across this connection. So क्या क्या दिया है इसमें आपको? Temperature is given to you. Sensitivity, see, the sensitivity is also given to you. Okay, for this sensitivity is for your material. So you need to find out the sensitivity at these junctions. So for that junctions, how to find out the sensitivity? Now observe that for this copper it has 1.9, and for constant ton it has minus 38.3. This is value is already in minus, right? So you can say that this constant ton wire has a negative potential compared to this copper. Okay, so I just mark the polarity here. This is your minus, com- and this potential is your plus. The same way, this is a constant and wire connected to this iron metal. So this is also minus with respect to with your iron. Okay, so this is your potential. Now you need to find out the potential across that junction. So now let's say this is your E2 and this is your E3. Now once you find out this E2 and E3, apply the KVL here and you can easily find out this E voltages. Okay, so how to find out this E? So for finding out this E voltages, E is nothing but your this sensitivity, which is provided you in terms of this Seebeck coefficient, you can say. into temperature. Okay, junction temperature, which is provided you. Now, this formula, by with the help of this formula, you can easily find out this E. Now, how to find out the sensitivity? Sensitivity is given for the particular metals. Okay, so that you already observe that the which metals has the lower means for that junction you already create the potential, right? Now, if I consider this, this is your positive junction and this is your negative junction. So you just write here first is, for example, this iron and this constant term. First term is iron and second term is constant term. So this is nothing but your sensitivity, which is Si minus of S constant term, because this is a one is positive terminal and another is negative terminal, right? According to this polarity. Now put the value of these metals to this sensitivity. So कितना है आयरन का सेंसिटिविटी 13.3. Okay, 13.3. And what is the value of this uh, constant wire का minus 38.3. So this is your minus 38, means it become plus 38.3. कितना आता है इसको ये करो
51.6.
51.6. Unit is microvolt per degree Celsius, already specified in your question. Okay, similar way find out all junction sensitivity. This is your first, you can say this is your junction, junction 3. Okay, junction 2, junction 2 का क्या होगा? Here you need to find out this copper and constant, this constructant, copper and this constructant. So this is your sensitivity of copper metal minus sensitivity of this constructant metals. Same way, what is the value of here? Copper sensitivity is 1.9 and minus of 38.3. So what is the value? I think 40.2, right? Microvolt per degree Celsius. Now, once you find out this sensitivity, find out the junction temperature, junction potential, which is E2. Find out this E2 and E3. E2 कितना आ रहा है? सॉल्व करो. सिंपल आपको इसको मल्टीप्लाई करना है उससे, टेम्परेचर से. ओके, फॉर जंक्शन T2 इज 50. 50 मल्टीप्लाई बाय दिस 40.2. So 40.2 multiplied by 50, you will get 2010. And same E3, when you multiply by junction temperature, which is given to 15 volt, right? Sorry, 15 degree, then you will get 774. So these are the value voltages in terms of your microvolt. Okay, these values in terms of your microvolt. Now apply the KC KVL here. KVL कैसे अप्लाई करूँगा यहाँ पे बताओ इक्वेशन. So consider any one of the polarity from these voltages. So I consider the this second polarity. Okay, so this E is positive. Second polarity for this is minus E3, and for this plus E2 equal to 0. So put that value. E3 की वैल्यू कितनी है? गलत किया गया. Okay, consider first polarity from this. Current flowing from that, for example. So this is your minus E1 minus E and plus E3 plus E2 minus E2 equal to 0, right? So E3 कितना आ रहा है इसमें 774 minus E2 2010 is equal to E. कितना आता है आंसर? फाइंड आउट करो. ई फाइंड आउट करना है इसका. ठीक है, सिंपल केवीएल अप्लाई करो और वहाँ पे उसका वैल्यू निकाल लो. लास्ट क्लास में जो हमने होमवर्क दिया था आपने किया उसे? Have you attempt this problem? यस, किसी ने ट्राई किया? क्या दिया था यहाँ पे? वोल्टेज सेंसिटिविटी कांस्टेंट दिया था 4500 वोल्ट पर दिस माइक्रोमीटर, राइट? So here what is given to you? V naught is equal to 127.3 वोल्ट. ई यंग्स मॉडुलस दिया हुआ है. ओके, सो ई वैल्यू इज 9 इंटू 10 न्यूटन पर मीटर स्क्वायर. you need to find out the you need to find out applied force, right? So use that formula which is already cover that derivation in last lecture. V is equal to G PT. P is pressure, so replace that pressure. So you can just replace that pressure is nothing but your E into epsilon. Okay, so in that case this is your Young's modulus which is given in your question, and this is your strain, right? So P is nothing but your E, and this strain you can write in terms of change in temperature, change in time divided by time, right? No, sorry, here T is for your thicknesses. Okay, thickness दिया हुआ है यहाँ पे. Okay, so this T is for your thickness. So simple PT is nothing but your E into del of T. Use that and put this value in this circuit. PT, so V naught क्या हो जाएगा आपका? G into this PT replace with this E into del of T. Okay, so put that value and find out the del of T from this. Okay, इससे जो भी आएगा यहाँ पे del of T आप find out कर लेना. And once you find this del of T, once you find out this del of T, so generally you can observe the unit for that. इसको यूज करने के पहले यहाँ पे देख लेना आपका किसका प्रोडक्ट आपको दिया हुआ है. ओके, generally this product is given to you in terms of this unit. So you just put that value in here and find out this del of t. Once you find out the del of t, use that formula, which is F by A, pressure is equal to E into del of t by t, right? T is given to you. Find out the, and all dimension is also given to you. Find out that and put that value in this, so you can easily find out this force, right? So from this you can find out this force applied to in this question. Okay, is there any doubt for this transducer? So we will cover in next class, and I suggest you please create a group and add me on that. Please make a group for this subject PMI and add me on that. Okay. So whatever the any information or regarding your this subject or any, uh, so I will put on that in that group directly. Yes, guys, those are in online mode. They can leave now. Thank you.